Alright, so let's actually play around with this form of the equation, y equals kx, and I'm actually just going to rewrite it. I'm going to substitute a number in for k. So y, it's equal to 4x. We're going to see what happens when y is equal to 4x, and then over here we're actually going to see what happens if k is the opposite of 4, so just a negative number. What happens if k is a negative number? Y equals negative 4x. Okay, so we have two different equations to play around with here, and let's just see what happens. Right, I'm just creating a table here. I might need to extend these a little bit later, but we're just going to say here's our t-chart, and here's x and y, x and y. Okay, so we're going to see what happens to y in both of these equations as x changes. Alright, so let's see what happens to y when x is, let's say, 1, 2, and 3, and 1, 2, and 3. So starting off over here with y equals 4x, I just want to actually change colors real quick again. And alright, so what's y equal to when I substitute 1 in for x here? So 1 in for x. Change that, there we go. And I'm going to rewrite this 2 more times. Y equals 4 times my second number. I'm going to substitute 2 in here. And then finally I'll substitute 3 in for x, and I'm just going to rewrap that equation around that value. So y is equal to 4 times 3 in this last case here. Well, we can see here that 4 times 1 will give me a value of 4. So when x is 1, y is going to be equal to 4. When x is 1, y is 4. When x is 2, well, 4 times 2 is 8, so y is going to be 8. And finally, when x is 3, 4 times 3 is 12. So when x is 3, y is 12. Okay, so what are we seeing here? Well, as the values for x increase, the values for y increase. And they're actually increasing at a constant rate because our constant of proportionality, k, it's equal to 4. So it's increasing at a constant rate. So what we'd say here is y varies directly as x, or y varies directly with x. As x increases, y also increases. And it's actually going to increase at the same rate. Okay, so let's go over to this other equation here, and I'm just going to do the setup real quick. Alright, so I'm just going to do the setup for that equation real quick. Y, it's equal to negative 4 times some number. And in fact, what I'm going to do is just copy that information and repaste it twice here. Get it one more time. There we go. Alright, now I'm just going to substitute these values into each of the equations. Okay, so now we're going to want to pay special attention to what happens to y when we substitute 1, 2, and 3 into this equation. Notice k, it's a negative number. So 1, 2, and 3, well, when x is 1, well, 1 times negative 4 is negative 4, so y is negative 4. When x is positive 1, y is negative 4. When x is positive 2, y is, well, negative 4 times 2 is negative 8, so y is negative 8. And finally, and in fact, I'm going to fix that 8 real quick. Okay, and for this last one, when x is 3, negative 4 times 3 is negative 12. So when x is 3, y is negative 12. In fact, I'm going to fix that too. Okay, so let's take a look here at what happens to y as x increases. As the value for x increases, notice the value for y is decreasing. That's doing the opposite here. Alright, and I'm going to actually just slide this information over just a little bit. Alright, so I thought it'd be kind of cool to play with a couple more numbers. Notice, so far we've just been looking at what happens to y as x increases. But what if we went the opposite direction? What happens to y as x decreases? So I'm going to plug 1/2 in here, half, and let's do 1/4 as well, 1/4. And then I'm going to do that over here. 1/2 and 1/4. Alright, so let's actually just start with 1/2. So y is equal to 4 times, and I'm not going to use parentheses, I'll just use that symbol, times 1/2 here. So what happens to y when we substitute 1/2 in for x? Well, I have 4 times 1/2, and we can think of 4 as a fraction as 4 over 1. All right, and just change colors. Okay, so this will give me, well, 4 times 1 is 4 over 1 times 2 is 2, and this will simplify, that will simplify into simply y is equal to 2. So when x is 1/2, y is 2. So when x is 1/2, y is 2. And I'm just going to get rid of a little bit more information here. All right, so this time we're going to substitute 1/4 in, so I'm just going to put a 4 in this denominator. So 4 times x, in this case 1/4. Well, this time I'm left with 4 over 4, so 4 over 4, which will give me y is equal to 1. All right, so I'm going to substitute 1 in. So y is 1 when x is 1/4. I'm just going to borrow that equation. Borrow it again. All right, now we'll play over on that other side. So what happens to y in this case when x is 1/2, but we have not positive 4 in this equation, we have negative 4. So this is negative 4 over 1, negative 4 over 1. So over here we have negative 4 over 2, and this will simplify into y is equal to negative 2. And over here I'm going to plug 4 in. What happens to y when x is 1/4? Now I have negative 4 over 4, and that is negative 1. So we have negative 1 here, and I'm going to go and write those numbers in. So y is negative 2 when x is 1/2. Y is negative 1 when x is 1/4. And I'm going to go get rid of some of this information below. I don't think we need it anymore. Okay, so what's all of this information in the tables actually telling us about direct variation? Well, earlier I said as x increases, y increases. But over here I stated that as x increases, y is decreasing, or y decreases. So let's actually go ahead and write that down. As x increases, as x is increasing, y is increasing, or y increases here. All right. But over here, as x increases, y decreases. So as x increases, y decreases, y decreases. Okay, so now let's actually go and take a look at what happens when we move in the opposite direction, or scale down, or as x decreases from 1 to 1/2 to 1/4. So as x decreases, we can see that y decreases from 4 to 2 to 1. So as x decreases, y decreases. But over in this other equation, we can see as you decrease the value for x, as x decreases, y is actually increasing from negative 4 to negative 2, from negative 2 to negative 1. So as x decreases, y increases. And let's go get all that information written down. All right, so over here for this equation, as x decreases, y decreases. Y decreases. So as x decreases, y decreases. All right, now I want to just point out here, I actually said if you start at 1 and decrease to 1/2 to 1/4, you actually don't have to do that. You could start anywhere along the table. So I could have actually said, well, what happens if x decreases from 3 to 2? Well, we can also see that y decreases from 12 to 8. So it's still moving in the same direction. You don't necessarily have to start at 1. All right, so over here, we said as x decreases, I need to change pen colors again. So as x decreases, y increases. So y increases here.